Okay, so welcome back. We are already started this S1.2, where in the previous section we have discussed about what is nuclear model of atom. We have talked about subatomic particle. Now we will continue with isotope. What is isotope and what kind of question you can get from here? All these things will be discussed in next video. So let's continue. Okay, so in this isotope, the most important is we should know what is the definition. What is isotopes? Isotopes, as you have seen in the previous example, that these are the atoms of the same element, and they have a same number of protons, but they have a different number of neutron. So in the definition also, we are going to add the same point, saying that isotopes are different atoms of the same element that contains the same number of proton and electron. But what is the difference? But a difference of different number of neutrons. So you will find that the neutron number is going to differ. So these are atoms of the same element but different mass number. In short, you can say that atoms of the same element but different mass number. And as we know, when you're saying different mass number, that means in mass number you have proton and neutrons, right? And we know that electron number is always equal to proton number. So what is actually going to differ is the neutron number in the isotopes, right? So we can say that actually there's a difference of proton number, right? So the way to represent the isotope is generally how we do. We just write, let's say, take an example. You have a carbon, right? So carbon have two isotopes. We can write carbon 12 like this. This is how we can write, followed by a symbol of the atom, followed by a dash, and the mass number like this, and like this, right? So carbon 12, carbon 14 like this. You can also write like this, 12C, or you can write C12 like this, right? Or you can write carbon 14 or 14C. These all notations are correct, right? So let's discuss about how, with some other examples, like we know the carbon, so let's discuss about hydrogen. So isotopes of hydrogen, right? So hydrogen, there's a three isotopes of hydrogen, right? First is your protium, second is deuterium, and the third is tritium, right? So if you want to draw the structure, it's very easy. Let me draw it for you. So in the protium, you have a nucleus and there is a one orbit where you have an electron moving. In deuterium, you have two protons, right? And there is an orbit in which electron is moving. In tritium, you have three, two neutrons and one proton, so that's a total three. And there's an orbit, electrons are moving. So when we have to write in terms of what they have, let's say proton number, let's see, neutron number, right? And we'll see the symbol how we can represent I, isotopic symbols. So they have one proton, they have also one proton, they have also one proton. Neutron, here you have 0, here you have 1, here you have 2. So this is neutron, neutron, right? This is neutron and this is proton. There is one proton here. And how to write? H11. If it's something written like this is protium, H12, H13, right? In this way we can write. Now when it comes to calculating the relative mass, let's take an example how we can calculate. How to calculate the relative atomic mass, right? Let's talk about that. This is very important. IB asks questions from here. Calculating relative atomic masses. Now, what is this, first of all? What is relative atomic mass? So, the relative atomic mass is actually this part is written as AR like this, right? So, it is how to define. You can say that the relative atomic mass of an element is the ratio of average mass of the atom of an element to the unified atomic unit. Or you can say there is one more way to define it. You can also say that the average mass of one atom of an element compared to 1/12 of the mass of an atom of carbon 12, right? That also comes under definition. So either you can write this definition or this definition, both will be correct. Now the question is how to calculate. Let's talk about that. How to calculate relative atomic mass. We will also discuss with one example how the mass is calculated, right? So let's see the process, how to do the calculation. So first, the mass of an atom or mass of an element given as relative atomic mass by using an average masses of all the isotopes. So the mass of an element is given as relative atomic mass, that is AR, by using average masses of all the isotopes. Next, the relative atomic mass of an element can be calculated by using percentage abundance, how much they are, right? So we can say that the relative atomic mass of an element can be calculated by using percentage abundance value, right? For example, let's take an example. Find the mass of, let's say, 100 atoms by multiplying the percentage abundance by mass of each isotopes. So then you will get. So how to write the formula for the total mass? So I can say total mass of 100 atoms equals to percentage abundance of, let's say, A isotope into mass A plus percentage abundance of, let's say, B isotope into mass B. And like this we can go ahead, right? And then what you have to do, then how to find relative atomic mass. Now you got the total mass of 100 atom from above formula. Total mass of 100 atom divided by 100. That will give you the relative atomic masses. So let's have one example to understand how these works. I will take a very good example which always IB asks. Let's say question is the sample of oxygen contain following isotopes. Fine. Now what are the isotopes? Let's say oxygen 16. Percentage abundance is, let's say, 99.76%. Oxygen 17, percentage abundance is 0.04%. And oxygen 18, percentage abundance is 0.2%. Question is, what is the relative atomic mass of oxygen? And you have to write in two decimal places, 2 dp. Very important. If the question asks in two decimal places, you must write in two decimal places. How to solve? Now, how to solve? Let's see. Let's calculate the total mass. Total mass of 100 atoms. How to calculate? As we know, percentage abundance of the first isotope is 99.76. And how much it is? Mass is 16 plus. Second is 0.04 into 17 plus 0.20 into 18. And after doing all the calculations, you will get 1600.84. I'm getting 4. Sorry. Yeah, 4 4. The mass of one atom. How to calculate mass of one atom? So one atom will be 1600.44 divided by 100. So I'm getting 16.004. So the relative atomic mass is 16.00. That is at two decimal places. This is the answer. And this is how we can calculate the number of isotopes very easily. And we'll discuss about how we can interpret this spectra information to find out the relative masses in the next lecture. Thank you.